Okay, in this video we're going to talk about how we can start splitting our renders using Redshift into separate render components called AOVs. And AOVs stand for arbitrary output variables. And it's essentially a way to break up our render into its different major components. So to think about that, if we take a look at a render here that we have of this scene, let's take a look at the different kinds of lighting and components that we have on these given objects. So I'm just going to come into my Redshift render view. And here I have a render of what this scene looks like right now. And what we see is we have a couple basic lights in this scene. We have a big dome light, right? That's got an HDR image applied to it. We have a spotlight coming in from this direction, and we have a spotlight coming in from this direction as well. And so we're seeing those reflections happening here off of this kind of metallic looking torus. We have a refractive cube here and sort of a Scotch glass here with a lot of refraction and reflections on it. We have this sort of shiny displaced sphere, and we have a little pyramid that has an emissive texture on it. Right, and so what we're seeing is a bunch of different sort of lighting and material interactions that are going on in this scene. So when we think about the different components of this scene, we can think about things like the standard diffuse element. We can think about the highlights as separate components. We can think about the refractions as separate components. We can think about the global illumination in the scene that helps the light to bounce around a bunch as a separate component. We could even think about the normals of any one of these objects as a separate component. There are a bunch of separate components that all contribute to the overall look of the scene. Even something like the little caustics that we see down here from the light refracting through this glass and kind of getting dispersed a little bit here on the reflective floor. Right? Those are all things that we can separate, and by separating them, we can recombine them in post in a software like Nuke or Fusion or After Effects, and then have a lot more control over the overall contribution of any one of those components, way more so than if we just render this out as a single image where all of those things are basically baked together. And that gives us a lot more control in the compositing stage and gives you a lot more control of your overall renders. So in this scene, I just want to kind of show you what my basic setup is so that you kind of understand essentially the most basic AOVs that we will principally always use, and the ones that are kind of the easiest to composite into After Effects, which is the software that we're going to be looking at specifically here for our compositing. One other element that I didn't mention is just something like the shadows as well. Okay, so looking at the scene in general, just a couple things to note about the setup. I have a dome light here, and as I mentioned, the dome light has an HDR texture plugged into it, and that's providing the primary lighting in the scene. All right. I don't have my samples cranked up super high or anything at this stage, and those are all things that I could push up higher later on if I wanted to. I do have a couple spotlights. They're sort of hidden over here. I got one up here. If I take a look at this scene from a different view, you can probably see them. I got one coming in from that angle, and I got another one coming in from that angle there. And those spotlights are set up so that they behave like a standard spotlight, but also when it comes down to Redshift, the Redshift options here, under photons, I have it emitting caustic photons as well as global illumination, or GI photons. And that's the same for the other light as well. And that's just important to note, because if I don't enable caustics on here, then the light itself is not going to emit them, and we won't see them. So that's an important thing to take note of. You don't have to emit caustics, it's just it adds a little bit more realism to the scene, and the higher the photon count, the more realistic the photons, or the more realistic the caustics will be. Okay, just some basics about the materials in general. I am using a Redshift material on basically all of my objects in this scene. And so just dealing with ones that are, in this case, more of a metal overall kind of material. Here I have one that's more like glass. It's quite quite reflective and refractive. This one is also refractive. This guy here, which is a sphere, as you noticed in the render, it has a big amount of displacement on it and a lot of reflection on it. That is as a result of, in my hypershade, pull open my hypershade real quick. If I were to take a look at that specific one, sphere here, let's just map that one out. Actually map out the shading group. There we go. You'll notice that plugged into the shading group for the sphere under the displacement shader section, right? I have a Redshift displacement node that has plugged into that a file, which this just happens to be one of the default ZBrush alphas. I just chose it at random. It doesn't really have any specific setup or whatnot that makes any real sense. It just provides a lot of displacement. And I've kicked, the displacement is actually at its normal scale there, so it's just kind of doing its default thing. But it does provide us with this kind of cool looking displacement that we saw here in the render. The pyramid here has an emissive property to it. So if I come down to overall, my emission weight I've turned up to 1, and then the emission color I've turned to white. This one here, this one actually has a little bit of rotation on it. So if I were to scrub the timeline, you'll see that it rotates around like that. However, and the reason why I did this is to work with motion vectors. However, motion vectors are not something that work well with After Effects by default. You'd have to purchase a plugin to really make the motion vectors pass work well with After Effects. And so I'm going to leave that out of the discussion for this video. But I will just mention that as an aside. So this is just it's another Redshift material, but it has a little bit of a more matte kind of coloring to it, surface to it. Then we have our floor. Our floor is a checkerboard, right? And it also has some reflection to it as well. I don't have a background in the scene. I could put one in there if I wanted to. I've turned off the visibility of my dome map, so we're not actually seeing that in the background there, and that's okay. So when I go to render this, as I've shown you this render here, you can see all those properties that I mentioned. But how do we start separating this into the different passes? Well, here's how we'll do that. We'll come up into our render settings, and let's take a look at our basic render settings to begin with. I'm going to call this AOV test. I'm having the image format set to OpenEXR because EXRs tend to be our best format when we're doing compositing. And I'm also setting it up to a very high bit depth, 32 bits. It means that the files will be larger than normal, but it also means that they'll have the maximum amount of color data in them, and therefore the best for doing any kind of overall image adjustments. I will also want to make sure that if I am planning on rendering this out as an animation, I turn on animation and I set my frame range. In this case here, I'm just going to render frame 7 to frame 7 because that's all we really need at this stage. Or I can render frame 1 to frame 1, but we're currently on frame 7, so I'll just stick with that. Now, are there any other things here? Just basic image size settings. Let's go to the output real quick. The output here, I don't have it very high samples. I would actually crank this up much higher if I were planning on outputting this for real. But this is good just for our overall test, right? If you are working with motion blur, you would have to make sure to enable it here under the motion blur section. But since we're not going to worry about that in this case, I'll just leave that off. And all the rest here should be fine. Now, the big section for us to look at is the AOV section. Okay, so let's talk about the different AOVs, or arbitrary output variables, that we're going to work with for this example. Ambient occlusion is one that you may have heard of before, and it really allows us to go through and check what the overall sort of shadowing or darkening parts of the scene are. It's wherever there is a sense where the light is not being as intense and it comes out looking more or less like a shadow pass. However, we don't necessarily want to work with the default ambient occlusion AOV here in the more recent versions of Redshift. We will want to work instead with a more recent development in ambient occlusion in Redshift that we will stick into a custom AOV, which we'll come back to here shortly. So the first ones that we want to apply in here, we're just going down in alphabetical order, will be our caustics. Okay, so we'll add in caustics, and then we're going to add in a depth dimension that's going to be able to allow us to see visually which objects are closer and which ones are farther away, right? Actually, as we go through these, let's just take a look at their values. So caustics here, if I go into my attribute editor, as you'll notice, by the way, the default bits per channel is set to 16 on most of these, and it's okay if we leave it like that, but you could boost this to 32 if you wanted to keep everything consistent. I'll leave it as it is because it's not really going to be much of a difference in this case. However, on the depth field, it's not such a bad idea to have your bit depth set to something like 32, just because it's really good when you're trying to work with creating your depth of field in After Effects to have as much information there as possible. So we'll leave that there at 32, all right? We'll also want to come in here, I'm just looking for a custom AOV, which we didn't actually see at first because we're kind of scrolled down. There is a custom AOV here at the top, and we're going to grab that one. We're going to add that in. And this custom AOV is what we're going to call AO. And we're going to make this our ambient occlusion pass, right? We're not using that ambient occlusion. We're using the custom channel to do that. So click on custom here, and it's going to ask us for what do we want as our default shader. And this is where we're going to add in a custom shader. So we'll click on the little checkerboard right here, and we'll come into our Redshift options, and we're going to look for a Redshift ambient occlusion shader right here. We'll just double click on that. We'll just click on that. And the default values here are probably fine, although I could increase the samples if I felt like there was too much noise in the ambient occlusion AOV. But for now, we'll just leave that as is. So far we have our caustics, our custom AO, and our depth or Z paths. All right, now as we come down here, we'll see that we have three options for diffuse. We have diffuse lighting, which is actually what we're going to use. I'll just add that one in right now. But we also have the lighting raw and the diffuse filter. Now, this has to do with the way that the certain passes are pre-multiplied or post-processed. If we combine the filter and the lighting raw, we should get a result that basically looks like the diffuse lighting, but it is a little bit more, I think, flexible for us in terms of color correction if we combine filter and raw. However, I don't want to go into that level of depth right now. The straight up diffuse lighting on its own will be fine, so we're just going to stick with that. We also have an emissive material, so we're going to add in the emission pass. Global illumination, just a straight up global illumination will be fine. We're skipping over a few of these here. Like I mentioned, motion vectors is something that without purchasing a third-party plugin for After Effects is not something that works really well for us. And the normals also. Normals is a really great pass because it can allow you to relight your scene in the compositing stage without having to go in and actually relight it in Maya. However, it's a bit limited in terms of what we can do with that in After Effects. If you are working in a software like Nuke or Fusion or something like that, you can get a lot more mileage out of the normals pass, and it can be really, really beneficial and very helpful. But that's kind of outside of the scope of this particular lesson that is more focused on how to bring this stuff into After Effects specifically. So we're going to skip over that one. We also have a few AOVs that allow us to create some mats based on either object IDs or material IDs. We don't really need to worry about that at this stage, but it is a way to create some custom mapping to be able to allow you to create per color based keys inside of After Effects. So that's something you might want to look up on your own later on. We're going to be looking at our reflections, just straight up reflections. There we go, add, and refractions. All right. So far with all these, I've not really worried about checking the values in here because all the default values are probably fine. All right. Shadows, we can create a shadow pass if we want, and that's fine, but the ambient occlusion pass is probably okay for us at this stage. We do want the specular lighting, however. That's going to be our highlights, so we'll choose that. We don't have any subsurface scattering going on in our scene, but if we did, we'd want to add that in separately. And I think, is that all that we need here? What other ones are there? Just looking through here. We don't have any volume lighting. If we did have any volume lighting, then that's something we would want to add in, but that's not the case in this scene. And another cool one is called world position, but it is also something that you essentially need a third-party plugin to work well in After Effects. But the world position value can be very useful in a software like Nuke natively or Fusion, and can allow you to do some really cool mats based on the 3D position of objects in your scene. So we're just going to skip over that. So what we have right now, just to reiterate, is at the top we have a caustics, we have a custom AOV with the ambient occlusion material or shader applied to it, depth shader, diffuse lighting, emission, global illumination, reflections, refractions, and specular lighting. Okay, almost ready to go for this, but we do have to make sure that we turn a couple other things on first before we go for broke here. So we're going to choose not necessarily opt. Opt should be fine as it is, but if you find that for whatever reason your scene is not calculating enough reflection or refraction passes to make things look right, you might increase the maximum trace depths. And other than that, that should be fine. However, global illumination, we do want to make sure that this is on. So the primary GI engine, it's set to brute force. We don't necessarily need to worry about a secondary engine in this case. 16 rays is usually fine. And then also under photon, we want to make sure that enable caustics is also on. And the default settings here should be fine as well. We don't have any subsurface scattering in this scene, so I don't worry about that. And the rest of these options should be fine on their own. I don't think I need to worry about those. So making sure that those default options, making sure that those options are on, will help us get to where we need to be. Okay, so when we go to render this, we have two options. We can render it just using our standard render view renderer. We can also render it using our Redshift renderer. So let's just go into the Redshift render view, because in the Redshift render view, we can get a preview of what all of these AOVs look like as well, and they will also be written out to disk. So if I click on the little render button here, it will start rendering my scene. The render is going to look at this stage like it already does, so it's a little bit misleading. But in the background, it is also creating a bunch of AOVs now that I didn't have before. So I'm going to pause the render for a moment, or to pause the video for a moment while this finishes rendering, and then we'll be back here shortly. Okay, we have finished rendering now, and let's just take a quick look at our AOVs. So if I come into this little drop-down menu here, you'll now see that I have all of the different passes. Now in that Z pass, I'm not seeing anything at this stage. We'll talk about that here shortly. The caustics, this is what the caustics contribution looks like. The AO pass, this is what that looks like. You can see that it's a bit chunky here in some sections. And so if I really wanted to improve this, especially when it comes on to like the refractions and reflections, I might want to go into my AO pass here. Let's just go into where that's located and see if I can go to my ambient occlusion there. I'd probably want to up my samples there, for instance, and see if that would help. But for now, we'll just leave it as it is. We're not going to be overly concerned about it at this stage. Diffuse lighting. Okay, so this is just a diffuse component of the lighting compared to the actual standard render. And you can see that that is quite different. And you'll see that in certain objects, like the reflective refractive objects, that there is basically black because their main components come from the reflections and refractions. Then we have the emission element, which is just the white that's sitting there on that cone. Global illumination, this is basically the light that's bouncing around the scene. And the reflections, you can see just the individual reflections here combined with the refractions, and then the specular lighting itself, which is essentially the highlights in the scene. More than just the reflections, it's really the highlights themselves. Now let's just quickly talk about that Z pass that we didn't get a proper render on, and let's talk about why. We need to go back to the Z depth AOV, and the major issue for this has to do with our depth settings. So right now they're set to, filter is set to full and depth mode is set to Z. We're going to get better results here if we set our filter to min depth and our depth mode to Z normalized. And we are also going to turn off this option for use camera near far, because that's sort of an automatic calculation. And we want to have more control over exactly where the min depth is, the depth closest to the camera, and the depth farthest away from the camera. But we can tell those things. We have a pretty good approximation of those things. The min depth is going to be 0 because that's right in front of the camera. And then the object that's the farthest away, if we take a look at that in our scene here, persp1, is that sphere. So if I click on that sphere, let's come back here to persp, right? What I want to do is I want to get a sense of how far away that is in world units. So I'm going to come up to display, heads up display, and we're going to go to object details. There it is. All right, and that right now says distance from camera of the sphere is 55.812. All right, that's usually the center point or the midpoint of that object. So just to be safe, I'm just going to say, hey, let's set the value there for our max depth slightly bigger than that to 60. So come back here to our depth pass, right? Set our max depth to 60. And let's go ahead and try rendering this again and just to see what it gives us. All right. And oops, not that one. There we go. And so I'm just going to go ahead, re-render everything and see what it gives us.